In this video, we are going to be talking about approximation. Now, in approximation, you move a number, say 2.45, to a nearest value that's close to this number, depending on how you are told to do it. Now, the probable problems you are likely to meet in approximations is the probable problems or forms of numbers that you need to approximate is in decimals and integers. So for decimals, we have a number with points and then numbers after those points. But for integers, these are just simply whole numbers. Now, to deal with approximation, we often get to approximate our values in three methods. So the first method is the significant figure method. The second method is the decimal places method. And then we're also asked to do that in tens, hundreds, or thousands, right? So throughout this video, I'm going to be visiting each of this step of the process. Okay, so for significant figures, say we have a number, this first example. So the key here is to start counting from the first non-zero number, right? So 0 is a zero number, and then all other numbers from 1 to any other number, so infinity is a non-zero number, right? So you need to start counting from the first non-zero number. Now, looking at this part, the first non-zero number here is the first number, so we are going to count 3 of those. So this is 1, 2, 3. Now, all other numbers apart from these 3 numbers would have to be eliminated, but we have to pick the first number and round it and then add it to this number. So for numbers that are between 0 to 4, we round them down to 0. The numbers that are between 5 to 9, we round them up to 1, right? Okay, so this number is a 3 and it is between 0 to 4, so it will be rounded down to 0 and then added to this number. This means that we have 9.45 as the interpretation of this number to 3 significant figures. Okay, so for a second example, we are asked to round it to 2 significant figures. This means that the first 2 non-zero numbers are to be counted. So this is 1 and then this is 2. And then this means that the rest numbers here would have to be eliminated. Now, this number is the last number in those set of numbers, the first number in those set of numbers. 7 is between the range of 5 to 9. This means that 7 is rounded up to 1 and added to this number. It becomes 19. So 19 to 2 significant figures is the form of this number. Now let's pick an integer form of this problem and solve. So an integer form will be 15150, and then we are asked to round it to 2 significant figures. Now this one is a bit straightforward too, but it's going to be a bit different from the rest. So we have 15150, that's 15,150. So we are looking at the first 2 numbers. So the first number is 1 and the second number is 2. Both of them are non-zero numbers. So this means that the rest numbers would have to be eliminated, but not really eliminated as in the decimal place form, right? Okay, so we have to round this number 1 is rounded down to 0 and then added to this one, so this becomes 1 5. But unlike in this case, when we are dealing with whole numbers, we do not remove the numbers totally, so they are represented by zeros, right? Okay, so this means that 15,000 to two significant figures. Let's take another example. So in this case, we count the first three non-zero numbers. This is 1, 2, 3. And then for these three numbers, we have to eliminate these ones, but not totally eliminate them, because this is a whole number, unlike in the decimal form. Okay, so this is 187, and then this number is rounded down to 0, then added to this number, still 7. So these numbers become 0. Right? Okay, so this is the form to three significant figures. Another thing I would like to add for significant figures is, say you have a number 10134 to three significant figures. Now in this case, if you're counting the number, we have to count 0. Right, we have to count 0 because 0 happens to occur in between two numbers. Assuming it was here, we are not going to count it, but here we have to count the number. Okay, so this is 1, 2, 3, and then the rest would have to be eliminated or turned to zeros. So before that is done, this one is rounded down to 0 and then added to this one, so this becomes 0 1 0 1 0 1 0 0 2 3 significant figures. Now for whole numbers, remember I said the numbers can be done in terms of questions you'd meet is in decimal forms or integer forms, that's whole number forms. So for the integer forms, this, once you round these zeros, you turn the numbers into zeros. So these zeros are called trailing zeros. They are called trailing zeros. Now let's quickly look at decimal places. Now decimal places works a bit different from significant figures. You have to start from the decimals while counting your numbers. So for this decimal, this number is the first number, second number, third number, meaning that this is the number that would have to be eliminated. But before that is done, 4 can be rounded down to 0 and then added to this next number. This means that we have 9.453 to 3 decimal places. Now let me quickly take another example to 3 decimal places. Okay, so in this case we have, after the decimal points, we have one number, two number, but then we don't have a third number. Now watch what will happen now. This thing becomes 18.72. We'd have to add another 0 here to complete 3 decimal places in this case, right? Okay, let's take another example. We have 0.6554, here's example 3, to 2 decimal places. Now I'd like you to pause the video and try this one out yourself. Okay, so to 2 decimal places, 0.6554 becomes one number, two number, and then we have to eliminate the rest here. So this becomes, this number is rounded up to 1 and then added to this number, so this becomes 0.66 to 2 decimal places. Okay, so we are going to be talking about approximation in tens, hundreds, and thousands. So let's quickly jump into one example. So we have 145. Now you should note that 10 is two numbers, 100 is three numbers, thousands and four numbers, 10,000s, five numbers. So this means that when you have a number, so from the right you start counting two numbers. So for this case, the two numbers is 5 and 4. Say we had to do this approximation to the nearest 10. So you start counting from the right, and then this is the first two numbers. So we are looking at these two numbers for approximation in this case. Now we know that 1, 4, 5. Now the most important number is the number from the left of those two numbers. So from the left, the number we are looking at is 4. Now we are going to have to round up this number and add it to that number that we are looking at. So rounding up 5 becomes 1, adding the ones 4 becomes 5. So to the nearest 10, 145 is 150. To the nearest 10, to nearest 10, nearest 10. So let's pick another example for it to be clearer. So we have, say, 68. 68 to the nearest 10, to the nearest 10 is from the right. We have two numbers already here. Now the most important one we're looking at is 6, and then we are going to have to approximate this value, round this value, and then add it up to this one. Meanwhile, this one will have to turn to 0. So this is rounding 8 becomes 1, and then adding 8 to 6 becomes 7. So this is 7, 0 to 10, to the nearest 10, to the nearest 10, to the nearest 10. So let's take extra example, nearest 10. So looking at this now, these are the two numbers we are picking because we are approximating to the nearest 10, and then this is the one we are looking at. So the number before that would have to be approximated to that number. So this number is the number before that. So 5 rounded up is 1, added to 4 is 5. So 650 is the approximation of 645 to the nearest 10. Okay, so let's take another example for hundreds. Okay, fifth example. So we have 677 to the nearest 10. Nearest 10. Now I'd like you to pause the video and do this one yourself. Okay, so the idea is still the same thing. We're looking at these two numbers from the right. Now the most important one is the last one, or the first number from the left. Okay, so you're going to have to round this number and add it here. So this is 6, 7 is rounded to 1 and then added 7 here. So this is 680 to the nearest 10. Nearest 10. So for hundreds, is still the same logic for hundreds. So we have 1750. For hundreds, remember 100 is three numbers, right? So we are looking at the three numbers, first three numbers from the right. So the first three numbers from the right is this number, and this number. So the first number from the left is this one, which is the number we are looking at the most, and then the number before that is what we are going to be looking at to approximate, to round, and then add it up to this number. So we are looking at this number most importantly, and this one, right? Okay, so this is 1. This number can be rounded up to 1 and added to this number. So that means that we have 1800 as this number to the nearest 100. Okay, let me quickly take another example. We have 1777. It's the nearest 100. It's the nearest 100. Nearest 100. So we're looking at the first three number from the right. Okay. And then the first number from the left is 7 here. So we are looking at the number before that number, which is this 7. That's the one that's going to be rounding up or down to add to this one. So this is simply 7 rounded up is 1, added to this one is still 1800. Okay, so let me take another example. We have 185577. It's the nearest 100. It's the nearest 100. Now in this case, still the same thing. First three number from the right. That's what we're looking at. And then the first number from the left of those numbers is 5. Now the number before that is very important because that's what we're going to be rounding up or down and adding to this one again. Okay, so this is 1857 can be rounded up to 1 and then added to this one. So this is 6. So the numbers after that become 0, 0 to the nearest 100. It's the nearest 100.